Hertzian dipole antenna. Okay, there are many names. You can call it as infinitesimal small antenna. Okay, infinitesimal small antenna. Infinitesimal antenna. I think some other names also there. So what is Hertzian dipole antenna? Then length has to be less than lambda by 10. That is, length should be very, very less than lambda. And again, you know that Hertzian, and again, what is the polarization of this Hertzian dipole? Because generally the polarization is linear polarization. Generally the polarization is linear polarization. Linear polarization. I will tell you why it is linear polarization. Because once if you place your antenna like this, okay, this is your antenna. If you are placing your antenna like this, okay, then it will produce the wave like this. Electric field will be like this. Then the magnetic field may be in the upward direction. Once if I place antenna like this, then my electric field may go up, my magnetic field may go down. Or once if I place antenna in the slanted manner, the small antenna, then my electric field will be in this way, and correspondingly there will be magnetic field in some other way. So what is finally what is important? The direction of electric field is important. Here completely horizontal polarization, here completely vertical. Here it's at some angle, that's it. That means what? Here also this is following the line, but it is linear polarization. So antenna polarization is linear. So Hertzian dipole antenna polarization is linear. And one more thing, what is the radiation pattern of the antenna? Generally the radiation pattern of the infinitesimal dipole or Hertzian dipole is always omnidirectional. Okay, radiation pattern is omnidirectional. Okay, finally we'll ensure whether that is following omnidirectional or not. What is omnidirectional radiation pattern? Anybody? Okay, so
It's equally in all directions.
no, sir. No, that
Horizontal.
is isotropic radiator. What is
Directional.
omnidirectional? Please be sure about what is isotropic radiator, what is omnidirectional antenna. Omnidirectional antenna radiates uniformly in the, not only one direction, it radiates uniformly in only any one of the plane. But practically it will radiate uniformly in the horizontal plane because peoples are present in the horizontal plane. But what is the concept of omnidirectional antenna? It radiates uniformly in any one of the plane, because we are having two types of plane. One is horizontal plane, another one is vertical plane. Once if you have two plane nature, then you can calculate the 3D nature, 3D radiation pattern nature, because we cannot visualize directly 3D. That's why we are using 2D radiation patterns. Okay, for 2D radiation pattern, we should have two planes. Okay, what is the radiation pattern? Horizontal plane. Then what is the radiation pattern in the vertical plane? What is the radiation pattern in the vertical plane? So what is omnidirectional antenna? It radiates uniformly in any one of the plane, that too practically in the horizontal plane, that too practically in the horizontal plane. Okay. Okay, for the time being, just you know the nomenclature. Then later I will show you simulation or pictures regarding this radiation patterns. Okay. So, so the polarization, so the radiation pattern is omnidirectional. Okay. In the exam, they'll ask this only, sir. What is the radiation pattern of Hertzian dipole? They will give you different answer. Okay, then you have to choose properly. Okay, so and then what is the polarization? Linear, circular, like that they will ask. Okay. So, so I took a Hertzian dipole. I took small Hertzian dipole. Please be careful. I am placing in which manner? Vertical manner. I am placing in a vertical manner. That means it will produce radiation uniformly in the horizontal plane, because as I am placing vertically, if the people go anywhere around this line, they will see the same line. They'll see the same line. That means what? They'll experience same field. That means I am not distinguishing the user on the horizontal plane. But what happens if some user goes above? If we seeing the plane from the base plane, then you'll see like a line. Once if you go above, then you will see as a point, then you will not receive any signal at all. That means what? This antenna will radiate uniformly in the horizontal plane. Okay, so then what I am interested, okay, what I am interested, I am somewhere, okay, I am somewhere here. This is my observation point. then what is from this observation point, then what is the electric field here, what is the magnetic field here. Okay, so this electric field and magnetic field I will directly write because we cannot do the derivation and all, it's very lengthy and that is not useful also exam point of view. So I will directly write the patterns. Okay, so you know one thing again, what are all the possible patterns, anybody? The possible patterns are, see, generally antenna analysis is always done in the spherical coordinate system. Okay, antenna analysis always done in the spherical coordinate system. Spherical coordinate system. Okay, spherical coordinate system, because you can do analysis in any coordinate system, but once if you do with this system, spherical coordinate system, then analysis will be a little bit easy as compared to others. Okay, so then you can have ER, E theta, E pi, and you have HR, H theta, and H pi. Somebody tell me, I am standing here, the wave is coming from here, in which direction the wave goes? This direction. Okay, I am standing here, my antenna is here, in which direction the wave comes? The wave definitely will go in this direction. That means what? Suppose if I stand here, the wave will come this way. If I stand here, the wave will come this way. So what is very clear here, you stand anywhere on the space, the wave direction is following r cap direction. Wave goes radially outwards. Okay, wave goes radially outwards. Once if you imagine properly, the wave goes radially outwards. That means wave goes in the direction of AR cap. Wave goes in the direction of ER cap. You know one thing, when wave is going in the direction of ER cap, wave is actually traveling in the direction of R, then definitely in that direction, as per the electromagnetic waves concept, because wave is not going in the waveguide, wave is going in the free space. Whenever the wave is going in the free space, definitely in the direction of R, you will not have any electric field, you will not have any magnetic field. I think this is already clear to you. So whenever the wave goes in a particular direction, you will not have any electric field or magnetic field in that direction, And okay, ER is 0, HR is 0. Then suppose you come to HR, okay, this is 0. Okay, this is already over. Then you may have, I have written wrongly. Okay, this is HR, R comma theta comma pi, HR, H theta, and H pi. Okay, so ER is 0, HR is 0, then E theta may be there, E pi, H theta, H pi may be there. Then my next question is, once again, for the moment I'll discuss about magnetic field. So once if I have a conductor like this, current is flowing either upward or downward, because you are really giving the AC signal. The current may go upward or downward. It's no problem. Then what could be the direction of magnetic field? Say for example, if it goes upwards, this is the direction of magnetic field. If it goes downwards, this is the direction of magnetic field. Now my question is whether my magnetic field is depending on theta, whether my magnetic field is depending on theta or it is independent of theta. That is my question, because you know what is theta. Theta means what? It is angle measured from the Z axis. So you know one thing, whenever you have a current, the current flows, let it be AC or DC, the magnetic field always depends on pi. Okay, because the magnetic field is having rotational nature. Magnetic field is always having the rotational nature. It is independent of what? Theta. It is independent of theta. That's why. So H pi may be there. So H theta is 0. So my magnetic field is independent of theta. So again, once if you do the derivation properly, then you'll get 0. But by intuitive analysis, I'm telling. Okay, so once if you have a current flowing on the conductor, definitely your magnetic field is present only on the H pi direction, A pi direction. That is rotational manner. Then this also becomes 0. Then finally, what is existing? H pi is existing. Finally, what is existing? H pi is existing. Then what is E theta and E pi you have to calculate, because we cannot make any conclusion about E theta and H pi and all, because if H is there, then really I have to apply the formula, because H pi is there. once if H pi is there, that formula is there, no, del cross H is equal to JC plus JD. In that formula, you have to apply H pi. Then that will give you the some value. Okay, so I cannot make any further conclusion here, because once if I know H pi nature, I have to really put it in that formula, because what is the formula is telling del cross B is equal to, okay, JC plus JD. JD is equal to what? Okay, dou D divided by dou T. Okay, dou D divided by dou T. So I have to really substitute in this formula. J by dou T means J omega epsilon E. So I know H pi. So because I can substitute here, then as per the formula, I have to proceed. Okay, then finally I have to conclude what is existing, what is not. Actually, this formula will directly give you ER is equal to 0. Okay, but I know already ER is 0. That's okay. But once if you proceed this formula, again you will get ER is equal to 0. You will get some component for E theta and H pi. You just think over once if you are in free time, because this is having component of only H pi. You know how to calculate del cross some B. Okay, let it be B or H. Okay, that's okay. You just substitute here ijk dou by dou x, sorry, dou by dou r, dou by dou theta, dou by dou by. Then you substitute only H pi value. Then what is the component existing? Whether really E theta and H pi is existing. I am telling E theta and H pi will exist. Okay, just when you are in free time, just to try to do this. Okay, so finally, what is existing? E theta, E pi, H theta, H pi. Okay, H theta, H pi. Okay, E theta, E pi. Let's wait a bit. Okay, so what is existing? E theta, E pi, and H pi is existing. So I will write down this parameter alone, this component alone. Okay, so what is H pi? H pi is equal to ideal sine theta. Okay, ideal sine theta divided by 4 pi. Ideal sine theta divided by 4 pi, and remaining component is there. That remaining component minus omega sine omega t c by cr. C means velocity of light in free space. R means distance between the observation point and antenna. Okay, then cos omega t divided by r square. Okay, so first I'll explain why this is like this. Okay, let it be electric field or magnetic field. This has to depends on ideal, because ideal is the source now. Okay, so ideal is there. Then what is the sine theta? This theta is this one. Okay, this theta is this theta. Okay, now you are at which angle? Because theta is always measured from the z axis. Theta is always measured from the z axis. You know one thing, whenever the source is like this, if your theta value is less, that means if somebody stands here, how much signal you will receive? You will not receive any signal at all, because he has to be on horizontal plane. My antenna is here, really I have to be on the horizontal plane. This is horizontal plane. I have to stand here, then only I will get the proper signal. But if my theta is 0, what is the meaning? The fellow is standing at the top of the antenna, is going upward to the skies, then definitely you will not get any signal. That is the meaning of that theta, sine theta. So once if theta increases, if theta is pi by 2, then you'll get maximum signal. You'll get maximum signal. That is the idea of that one. Okay, so okay, that is the idea of the sine theta. Okay, so ideal sine theta divided by 4 pi. And you are having two terms. Okay, this you will get by derivation. Okay, then here one more thing here. See, the first I will concentrate here. Anyway, this is constant for all. This will come for other field also, but only this will vary. And I am having first term and I am having second term. I'll see in first term what is happening. In first term, my field is 1. Okay, see 1 by r, because c is constant, omega is operating frequency, that is constant. This is sine omega t. Anyway, once if you fix omega, this nature also you know. So it depends on 1 by r, because r is not constant, because you have chosen a point here. You have chosen a point here, then this is r. You may choose anywhere. You may choose anywhere on the space. R can be anything. So when R varies, this function varies like this. Okay, and here if R varies, it varies like this. Now you think of these two functions when you are moving from the source. Okay, my source is here. You are moving from the source. When you are near to the source, say this is near, I am telling. Near means what? It's in your hand, because if you are in 1 meter, that may be near to you, or if you are in half meter, that may be near to someone else. So whenever you are near to the antennas, take R value very, very less. Once if R is very, very less, which field will dominate, sir? This field or this field? Okay, whenever you are near to the antenna, that means what? R value is very, very, very less. When R value is very, very less, which field will dominate? Anybody? When R value less means it can be less than 1 meter also. Please imagine that. Don't take always 1 kilometer, 2 meter, 3 meter like that. Anybody tell me which one will dominate whenever you are near?
First.
நல்லா யோசிச்சு பாருங்க. Sir, you take R near means you take R is equal to 0.2. 0.2 meter you take, sir. Which one will dominate? எதுக்கு அதிகமான வேல்யூ வரும்? What is mean by domination? இந்த ஃபீல்டுக்கு வேல்யூ அதிகமா வருமா, இந்த ஃபீல்டுக்கு வேல்யூ அதிகமா வருமா? Don't worry about minus and all. I'm just asking you, you take some value of R which is very, very small, then you calculate 1 by R or 1 by R square, which value will be high? எது சார் அதிகமா இருக்கும்?
Second, sir.
Yeah, second one. So that's why the second field is called near field. This field will dominate when R value is very, very less. But when R is less, this also will give some value, but this will dominate. Okay, this will dominate because it is giving more value. So this is dominating. That's why this field is called near field. When you go far away, see, when you take R very large value, which will dominate? Say R is equal to some 5 like that. அப்போ போடும்போது என்ன போடுவீங்க? 1 by 5, 1 by 5 square. Which will dominate? This will dominate. That's why this 1 by R term is called as far field. Okay, so 1 by R term is called as far field. So 1 by R is far field, 1 by R square is near field. In some cases 1 by R cube may come, then that is near or far field. In some cases 1 by R cube also will come, then definitely that is near field only, because 1 by R square itself is a near field, then definitely that also near field only. So in case of antenna analysis, definitely we will have two field. One is near field and another one is far field. Okay, then finally only far field is important. Okay, but at this moment I will write everything. So if H pi means this is far field, first 1 by R means far field and 1 by R square means near field. Then I will write another parameter E theta. What is E theta? E theta is equal to ideal. Okay, theta comma pi. Okay, E theta is equal to ideal sin theta divided by 4 pi epsilon. As it is electric field, it depends on epsilon. Anyway, ideal sin theta is the source. Then minus omega sin omega t divided by c square r plus cos omega t divided by r square c plus sin omega t divided by omega r cube. Okay, so from this, what is important? This depends on 1 by r. This is 1 by r square. This is 1 by r cube. So this is near field. Okay, this is far field. Sorry, I written wrongly. So whenever 1 by r comes, that is what? Far field. Whenever 1 by r comes, that is far field. This is far field. This is near field. This is also near field. This is also near field. Okay, then I take last one, that is E pi. E pi, that is 2 ideal sin theta divided by 4 pi epsilon cos omega t divided by c r square. Okay, sin omega t divided by omega r cube. Okay, so again this is near field. This is also near field. But as per antenna analysis, what you want? You need far field. Okay, once a far field is there, then you have to take it for analysis. It consists of only near field. So once if your observation point is very, very large, then you no need to worry about this one. The contribution due to this component is very zero, because whenever r is very high, the contribution of e pi is very much less. Then you can neglect e pi. So finally, what is surviving among all? What is surviving? E theta is surviving. Okay, then which one is surviving? H pi is surviving. Okay, because once if you consider only far field, what is surviving? Only E theta and H pi. Okay, because E theta is surviving because here far field is there, and H pi is also surviving, here far field is there. And again, see, far field means always 1 by R. So finally E theta and H pi is surviving. Okay, so I'll write further. Okay, you take some note. So what is important here? Uh, 1 by r square and 1 by r cube are strong. Okay, it produces very much high value when r is small. R is small. So that's why this is called as near field. Near field, or another name for near field is induction field or reactive field. Near field or induction field or reactive field. Okay, and 1 by r can be strong. Even again, you know, when r is increasing, 1 by r will decrease. That's okay, but as compared to this one, this is strong. That is the idea here. Okay, strong even when r is high, but that is compared with this term. Okay, this is always compared with this one. That's why this field is called far field or radiation field. Okay, radiation field or active field. Radiation field or active field. Okay, and again here, suppose I'm having like these structures in some book, instead of omega they'll put beta also, because you are having relation between, because omega and c can be replaced by what? Beta. Okay, because phase velocity and phase constant are always related with beta. So that's why this omega and c can be replaced by beta also. Some book they'll mention like that also. So that also I'll do, because you have to know these relations always. Okay, when you do the antenna analysis, sometime beta is equal to 2 pi by lambda, beta is equal to omega into mu epsilon, or otherwise velocity, phase velocity is equal to omega divided by beta. And this is because the wave is really going in the free space, so the phase velocity of the wave is always is equal to free space velocity. So c is equal to what? Omega divided by beta. Omega divided by beta. So you can replace. Okay, say, and again, what is beta? Beta is equal to omega divided by c. So whenever you have omega by c, some book they may write, instead of omega by c they may write beta also, some book. Okay, so and again, at some point, definitely as antenna is there should be some dividing line between the near field and far field. Okay, if this is near field, your antenna is here. If your antenna is here, if this is near field, then there should be some dividing line. Okay, this is far field. Okay, at this point exactly, near field is equal to far field. Okay, so exactly on the dividing line, what is the idea? Near field is equal to far field. Okay, because we have to identify that dividing line, near field is equal to far field. Okay, then what is the near field value? You take, I think H pi you can take. I think in H pi we are having both near field as well as the far field. Okay, you are having both near field as well as the far field. Then what is this value? Okay, what is the magnitude of the sine omega t? Simply omega divided by CR. Okay, then what is the near field value? Simply omega by r square. Here omega divided by CR. Okay, simply you take the magnitude and equal it. Okay, because actually sine may be positive or negative. Here also may be positive or negative. We take only magnitude, omega divided by CR and omega divided by r square. Then we can identify that dividing line. Okay, so near field value is 1 by r square, and far field value is omega omega divided by CR. Then from this R is equal to, what is R? R is equal to, I think this R will cancel. R is equal to C by omega. Okay, and again I told you C can be replaced by V divided by omega. Okay, V divided by omega. Okay, how can you replace C by omega? Because beta means omega divided by C. Then C by omega can be replaced by 1 by beta. Okay, so this is simply 1 by beta. R is equal to what? 1 by beta. But do you know what is beta? Beta is equal to 2 pi by lambda. Then this is lambda by 2 pi. So what is this dividing line? This dividing line R. Okay, because exactly at this value of R, when R is equal to lambda by 2 pi, then exactly near field is equal to far field. So what is this dividing line? Exactly this, at this place, lambda divided by 2 pi R. This can also, you can write it as 0.16 lambda, exactly at this distance, exactly at this distance. Okay, 0.16 lambda. Okay, exactly at this distance. From near field you are going to the far field. Up to this distance you are at near field. After this you go to the far field. Okay, so lambda divided by 2 pi. That's why I asked you to remember this finally. Okay, to remember this one finally. What is this? 2 pi by lambda, you just opposite. Okay, lambda divided by 2 pi, you simply remember like this. Okay, near field and far field separation. Okay, that's the idea. Okay. So next, I will take E theta and H pi nature. Okay, then right, what is E theta? Finally, what is surviving? Only E theta and H pi. Okay, E theta is equal to ideal sine theta divided by 4 pi epsilon. Now I am going to write only far field, because far field is going to only far field is will be going to the far away places. Now I will write only far field. Okay, I will neglect the near field and all. I will write only far field. So minus omega sine omega t c square r. Okay, c square r e theta. Then in case of h pi, what is far field? Ideal sine theta divided by 4 pi divided by 4 pi minus omega sine omega t divided by CR. Okay, finally what is surviving? Only what I have written now, E theta and H pi, far field component alone I have written. Far field component. I have neglected near field component, far field component. Because antenna analysis means far field analysis, only in far field, real field is there. Okay, so I'm taking only far field component. Okay, so once E theta H pi is there, now from this, you know what is electric field, you know what is magnetic field. If we take the ratio, what will happen? Or otherwise, before that, I am interested in which direction actually the power goes. Okay, this is my E theta. This is my direction of electric field. My electric field is only in the direction of E theta. My magnetic field is only in the direction of H pi. Yes, sir, H pi. Then in which direction really the power flow? Okay, this is A theta and this is A pi. Once if this is A theta and this is A pi, then definitely my cross product will be AR cap. Then what is the meaning? Really the power will be in which direction? PR cap, in AR cap direction. So if theta, electric field is in theta direction and magnetic field is only in the pi direction, finally my power will be going radially outwards. So I have to make sure that whether it is true or not. So what it is telling, always your electric field is in the direction of E theta, magnetic field is in the direction of H pi, then your power is actually going in the direction of R. Okay, how can I ensure? Suppose I am having antenna here, I take some antenna here. Now, please imagine that this antenna I have kept inside some imaginary sphere, Now I am on the imaginary sphere, okay, like 3D, okay, like 3D. So once if I am on the imaginary sphere, I have to make sure that really whether in which direction my power is actually going. If I stand here, somebody tell me at this place what will be the direction of theta and what will be the direction of pi, because at this direction the theta will be like this. Okay, this is the direction of E theta here, and really your H pi will be going like this. I think if you properly imagine, your H pi will go like this. Okay, E theta and H pi. Okay, so actually, and again, please wait a bit. But actually, once if you imagine properly, because you are at theta is equal to 90-degree plane, definitely when you are at theta is equal to 90-degree plane, your h pi will go like this. Actually, it will go penetrating inside the screen, but I cannot draw it here. That's why I'm drawing like this. But actually, exactly that is a point. Okay, or other. Okay, so it's exactly going inside the screen. This h pi is exactly going inside the screen. Then you tell me, or otherwise I can put this like this also, because at this place my h pi nature is going inside. Whenever some vector goes inside, that I can denote it as what? Cross mark. Whenever some vector goes inside, that I can denote it as cross mark. Okay, if it comes outside, dot. If it goes inside, that is cross mark. So this is my direction of magnetic field. So then you apply the right hand rule. You go from E theta to H phi. H phi is really going inside the screen, really going inside the screen. Then you apply the right hand rule. Then what is the direction of power flow? What is the direction of power flow? Then definitely this is the direction of power flow. This is the direction of power flow. Yes, it is correct. Then you apply here. Now in this, when you are here, what is the direction of theta when you are here? Okay, what is E theta? Okay, when you are here, your E theta, okay, in which direction E theta will be there, sir, when you stand here? Anybody? Any idea is that? Mhm. Plus x or minus x direction of E theta. In which direction E theta will be there when you stand here? Hmm? Any idea?
Sir, minus x direction.
Minus?
X direction.
Hmm. What about others?
The antenna placing vertical direction, is that?
Now my question is, when I stand here, what is the direction of E theta when I stand here? Please refer in coordinate system. Please refer what is the relation between A theta, AX, AY, AZ. இதை ரெஃபர் பண்ணீங்கன்னா தெரியும். If you have notes. If
Sir,
you have
minus
notes,
A,
என்ன ஆன்சர் வருது உங்களுக்கு?
minus AY direction.
மைனஸ் AY டைரக்ஷன்ல வருதுங்களா? எஸ், கரெக்ட். மைனஸ் AY தான். Okay, then you imagine what is the minus AY direction. Okay, okay, at least அதையா கண்டுபிடிச்சீங்களா? Okay. Okay, see, what is the relation, madam? What they given? A theta and AX, AY, AZ. Okay, what are all the relation they given? சொல்ல முடியுமா? இப்படி ஒரு ரிலேஷன் உங்களுக்கு இருக்குதானே? ரிலேஷன் between AX, AY, AZ and A theta.
ரெஃபர் பண்ணாதான் தெரியும், மறந்துட்டு.
Okay, please refer it. Yes. Okay, anyway, I will draw here because we need some answer. For that I will draw here, because but one thing is very clear. Finally, my power will go like this only, because this is the radial direction from the source. My power has to go in this way. Because why I am taking power like this? This I am assuming as like a point source, sir. But in reality, the radiation pattern may be anyway, but I do not know. But I am assuming this is like a point source. Point source has the ability, because this is very small, length is very small. I can consider as a point source. Okay, so but in reality, here the power strength may be really different. But if at all power is there here, then definitely it will go in this direction. But once if it goes in this direction, okay, then what could be my h pi? What could be my h pi here? Because what is the h pi here? Actually, when you are exactly on the x z plane, when you are, this is like, I know, I think you remember this one. This we used to draw like this. This is my x and this is my y, this is my z. If I am exactly on the xz plane, then what is the pi value? Pi can be anything. I hope you remember that. What is the pi value? Pi can be anything. When I stand here exactly, actually pi can be anything. And but I want vector in this way, but my pi can be anything. Okay. And when pi is anything, what is your a theta here? Okay, when you are exactly here, what is your a theta? In which direction a theta goes? Anybody? When you stand here exactly, in which direction a theta goes? A theta means what? It is always in the increasing direction of theta. Again, in the horizontal plane, your a theta can go like this, or like this, or like this, or like this. Your a theta also can be in any direction. So already your pi can be anything. A theta can be in any direction. Somehow it will give you the radiated power in z cap direction. So please refer your notes. When you stand here, what is your a theta? When you stand here, what is your a theta? What is your a pi? And please make sure that you know what is a theta here. When you stand here, what is your a theta? And again, you know what is your a pi. Okay, when you stand there, then definitely theta comma pi is always what? Er. Theta comma pi is always, but I know what is er. Er is what, sir? A z cap. Er is what? A z cap. Then what should be this one? Please refer your notes. So what I'm telling, you choose any point on the imaginary sphere. Finally, your power will go in the direction of AR cap. Accordingly, your theta and pi will vary. Because if I choose here, my theta may be different. If I choose there, my theta will be different. Then actually, finally, your power will go in the only R cap direction. That is the idea here. Okay, finally, power flows only in the increasing direction of R. Okay, that is important. Always power flows in the increasing direction of R. Increasing direction of R. Okay, that means power flows radially outwards. Okay, power always flows radially outwards. Power flows radially outwards. Accordingly, a theta and a pi will change its direction. Okay, that's the idea. Now I know what is E theta, what is H pi, what is E theta, what is H pi. If I take the ratio of the electric field to magnetic field, then you take the square root, because you know this relation. Okay, you know this relation. Theta is equal to always E by H square root. That means what? On the free space, you stand somewhere, you measure what is E theta, you measure at that point what is H pi, you take ratio and take square root, then finally you'll get intrinsic impedance. Now I have what is E theta. Okay, sir, E theta I have finally written. Then what is H pi? What is H pi? Then you take square root, whether that is really giving you eta or not. Then you refer far field of E theta and H pi. If you refer, I think you'll get E theta is depending on 1 by CR, then C by CR will come up, and okay, and you'll get C square R here. See, please refer E theta far field value and H pi far field value. Okay, then finally you'll get like this. So once again C cancel. Okay, C cancel. I think something is missing here.
Epsilon.
We'll check. I think epsilon is missing. Where, sir? In the denominator or numerator?
Denominator.
Yes, correct. So epsilon also will come. Then finally this is 1 by C epsilon. You know that C can be written as mu epsilon. Okay, so I think square root of mu epsilon like that. C can be replaced by like this. Okay, so yes, sir. I think the definition itself wrong. This is simply E by H, sir. I think yes. Eta is equal to only E by H, no? A square root comes. Anybody?
No, sir.
Yes, sir.
Only E by
It's
H.
mu root of mu by epsilon on the square root.
Square root varma.
Yes, sir.
Only E by
No,
H.
sir.
Only E by H. Okay. So once if it is only E by H, finally you are getting, okay, like this. R cancel, C cancel, 1 by C epsilon. You know epsilon means again C can be replaced by square root of mu epsilon. Then epsilon is here. Then this is finally square root of mu by epsilon. And you know what is mu by epsilon? That is 120 pi, or this is 377 ohm. And again, you know that this is the intrinsic impedance of the free space. Intrinsic impedance of free space. Yes, this has to be true because the wave is really going in the free space. But whenever the wave goes in the free space, really the electric field to magnetic field ratio will be eta only. The electric field and magnetic field ratio will be eta only. So eta is equal to what? E by H. That is 377 ohm. Okay, so intrinsic impedance of the free space. Intrinsic impedance of the free space. Okay. So next, and one more thing. But finally, we have concluded only we are taking far field. Okay, only far field because antenna analysis depends on far field. As the signal goes for a far away distance, we are analyzing only far field. Okay, whenever you have far field, definitely your electric field or magnetic field, let it be electric field or magnetic field, varies as 1 by r, and similarly even H field also varies as 1 by r. You know what is power? Power means what, sir? Either power means what? Product of electric field or magnetic field, or what? You can take it as E square also. Okay, எப்படி நம்ம பவர்னா V square னு எழுதலாம் இல்லனா என்ன எழுதலாம்? VI. In the simple sense I am telling. Okay, that may be consist of 1 by 2 something like that. That's okay. So in the simple sense it is product of EH or E square. Then that means what? Once if electric field depends on 1 by r, then power depends on what, sir? 1 by r square. Okay, so always power varies with 1 by r square. Power varies in this manner. Power varies as 1 by r. So electric field always varies in the 1 by r manner. Power varies in the manner of 1 by r square. Okay, in the manner of r square. Then one more thing is here the radiation pattern. What is the radiation pattern here? Anybody? What is the radiation pattern, sir? Starting less சொல்லிருந்தேன். Huh? What is the radiation pattern? Okay, radiation pattern is something similar to omnidirectional. Radiation pattern means what? Omnidirectional. Okay, so I'll see what is the meaning of omnidirectional. Okay, when you have omnidirectional, you will have uniform radiation in the horizontal plane. You will have uniform radiation in the horizontal plane. See, once if it is horizontal plane, that I can write it as azimuthal plane. Okay, azimuthal or horizontal plane. Okay, once if I have horizontal or azimuthal plane, this will radiate uniformly. This will radiate uniformly. So my radiation pattern will be like this. The antenna is here. Okay, so in the azimuthal pattern, when you are in an azimuthal pattern, what is this plane called? Theta is equal to pi by 2 plane. When you are at theta is equal to pi by 2 plane, theta is constant. Already when you draw the radiation pattern, r is constant. Then this is the pattern is like this. And one thing is here clear. This is also independent of what? Pi, because pi you can vary, but as you vary your pi, the signal strength is not varying. That means what? It is radiating uniformly in the pi. Okay, in the horizontal plane. See, that means what? My pi can go from 0 to 2 pi. 0 to 2 pi. once if I change, go from 0 to 2 pi, I can go anywhere on the circle. But what is not changing? Even if I am changing the pi, my field is not changing. So again, it radiates uniformly in the horizontal plane. So that means what? Radiates uniformly in horizontal plane. It radiates uniformly in the horizontal plane. Okay. Then next I am on the vertical plane. When I am on the vertical plane, please imagine properly. Next one is elevation plane or vertical plane. Elevation or vertical plane. Again, vertical plane can be formed by taking pi anything. Pi can be anything actually. To form a vertical plane, pi can be anything. Please refer coordinate system. Pi can be anything. Starting lesson apple cut பண்ணும்போது vertically you can cut it in any manner, but horizontally you can cut it in only one way. But now we are in vertical plane, so pi can be anything. But you have to fix the pi. You take some pi. So once if pi can be anything means, if my coordinate system is like this, I'll draw a coordinate system, then you can understand. Okay, if I am like this, if I am placing my antenna here, now when I stand here or here, I may get some signal. I am on the base plane. Now, if I move in this manner, what will happen? If I go here, I'm exactly above the antenna. Then I will not get any signal at all. But when I stand here, I'll get maximum signal. Similarly, if I extend this, okay, if this is X, this is Y, and this is Z, and this is minus Z. Similarly, if I extend this, if I stand here, I will get signal. But if I vary my angle, if I go here, I will get low signal. Okay, so here, what is actually happening when I am varying my theta? This is maximum. Here, this is minimum, and again, this is minimum, and again, this is minimum. Similarly, if I go in this manner also, I can extend this like this, minus Y, I can extend like this. When I'm here, I'm getting minimum value, but as I come here, I get maximum value. When I come here, I get maximum value. Because now I am on the horizontal plane, because I am on the horizontal plane, XY or X minus Y, both are same, all are horizontal plane. Now, if I come down like this, okay, if I touch here, then again I'll get minimum. So what is happening? But if you draw it properly on a plain 2D paper, I can draw like this. So this is my reference. Okay, this is my angle. Okay, now this is angle. Now the angle I'll always measure from this axis, base axis. Okay, so now what I am doing, I am varying my theta. Okay, if my theta is 0, okay, so yes sir, can I draw? Anybody, what is happening? How to measure theta actually? When theta is 0, what is happening? When theta is 0, are you getting maximum or minimum? Yes sir. Some confusion is there where how to measure theta, in which axis we have to position. Actually that antenna has to be positioned here, then theta has to be measured here. When theta is pi by 2, you are getting maximum value. But okay, so we'll come to that later. But the shape will go something like this. That means what? I'll draw the shape, that is important. Finally, the shape goes something like this. Okay, it's like this. What is the meaning of this one? Okay, that means what? Whenever you are exactly here, that means here you are getting maximum signal. Okay, but when you vary your angle, if you vary your angle in this manner, then as you go away from this point, you are getting minimum signal. That means what? When your antenna is here, if you are standing here, then you are getting minimum signal. Similarly, in this direction also, maximum to minimum. Similarly, again, you can extend this in this direction also. You'll get like this. So here maximum and minimum. So again, this is elevation pattern. This is like a elevation pattern. And again later I will give you the simulation or diagram to observe this. At this point you remember. So in the horizontal plane you are getting circle. Okay, horizontal plane diagram is like a circle, but in the vertical plane you are getting a figure of 8 shape, figure of 8 shape. Then once if you have these two plane nature, then once if you rotate in a proper manner, okay, once if you rotate in a proper manner, then finally you'll get the 3D radiation pattern. Okay, 3D radiation pattern. That means what? First, what you have to do, you rotate this in all possible way you want. Once if you rotate this, you will form a sphere. Okay, once if you rotate this, you will form a sphere, because in any way you can rotate, because you are having a circle. Once if you make 2 pi rotation, then finally you will get a sphere. But this is intersection of two plane, and again you rotate this also, you rotate this also. Okay, you can again you can fix the base axis and you can rotate with respect to y axis, vertical axis, or otherwise you can fix the vertical axis, you rotate with respect to base axis. Finally you will get the same shape, no problem, because anyway you can do. Finally you will get a shape like a tumble. If you imagine properly, this will give you a, I don't know what is the spelling, the tumble shape that is actually used for the exercise. I think you remember this. The boys used to use the shape like this, like, but it's something connected like this. Okay, you'll get a tumble shape like that. So, but this is a 2D shape, but if you rotate in any way you want, either in a vertical manner or in a horizontal manner, you'll get a tumble shape. But finally you need final 3D shape. Then you intersect this tumble shape with the sphere. Then what is the common point you are having? What is the common point you are having? That is your radiation pattern. That is your radiation pattern. So finally, if somebody tell me the final pattern is decided by this one or that one, you have circles are, you are intersecting with this parameter. Finally, your shape will be decided by whom? Generally decided by both, because you are intersecting both. Okay, you multiply, because not addition, just multiply, just find out the intersection point. Okay, see, this is a sphere, this is some other shape but not sphere, but whatever the point that is available here, definitely it will be available here. That will be finally decided by this one. Finally, if you imagine properly, you'll get finally this will be decided by this one. Then you imagine what is the 3D shape of this one. Anyway, that is very difficult to draw, but you please imagine, okay, how it will be. More or less it will be like an apple. Okay, because for apple, you know, this will come, the shape will come like this, and it goes like this, and it comes like this, it goes like this, and once if you rotate this, I think you'll get an apple. Once if you rotate this, you'll get an apple. Then you make this value as very, very minimum, then it's something similar to apple shape, 3D shape. But you know that apple is not a perfect sphere. Okay, it is having some, it is on the top and bottom, it is not having a proper spherical shape, that is actually going really inside. Okay, the bottom and top. I think, and there is another way also to get this shape. I hope if you have a balloon, sometime if you have a balloon spherical shape, you know that somebody, they'll try to connect this end with this end internally. They'll connect this end with this end internally. Then you imagine what will happen. I think the balloon will go like this. Really, the balloon will go really like this. Once if you bring internally, if you bring this side here and this side here, then that is also similar to the tumble shape. This is actually, once the balloon structure is actual radiation pattern, 3D radiation pattern of the Hertzian dipole antenna. Hertzian dipole antenna. Are you getting some idea, sir? Once if you observe the diagram, then only it will be very clear to you. But I'm giving you the imagination shapes. Okay. Yes, sir. At the topic, Polama. Somewhat you understood, if not completely, at least 50%. Yes or no? Okay.
Yeah.
Okay. So next one is power radiator. Okay, power radiated. You know that the power radiated formula is generally, if it is average, then this is simply 1 by 2 and E theta cap H pi cap. This cap is always used to identify the direction of power flow cap, because once if you know the direction, then power flow direction you know. Then this is watt per meter square, watt per meter square. And what is the total radiated power? This is total radiated power. Total radiated power is equal to integral P average ds, and this is the surface vector. You know, you can take any imaginary surface, because if the surface is I, it will give you the more surface area, then P average will decrease. But if you choose a smaller surface, imaginary surface, then area will be less, but P average will be I. So you can choose any imaginary surface, no problem. Then you substitute. You know what is value of P average? That is 1 by 2 E theta and H pi. You know what is E theta component and H pi component. You simply make cross product, and again no need to make cross product, because this is having only one component, this is having another component. Simply that is simply a product only. Finally it will give you some direction that I know already direction. Also simply instead of product you can simply multiply. Okay, simply E theta and H pi. Okay, so what I am telling, instead of doing all these things, what I am telling, you can do like this also, no problem. You take E theta value and H pi value directly put there. And again, you know what is ds. Ds means what? R square. What is ds, sir? I forget. R square sin theta d theta d pi. Correct? Ds equal to R square sin theta d theta d pi. You know what is E theta? What is H pi? E theta is function of what, sir? It is function of theta as well as function of r. Similarly, H phi also function of theta as well as r. Already again this consists of r sin theta and all. Okay, you do the integration, you do the cancellation and integration properly. Okay, if you have time, please try to do this, because this is very simple. Once if you do that, okay, finally you'll get some value. That value is 80 pi square dl by lambda whole square. 80 pi square dl by lambda whole square. Okay, whole square into I square RMS, I square RMS. See, what I am telling, finally, the total power radiated is equal to 80 pi square dl by lambda whole square. You are getting I square RMS. Okay, actually you are using pi. Again, you know that I can be replaced by IRMS also, because what is IRMS? IRMS equal to I divided by root 2. So again, appropriately you can modify. So actually you are using IDL, but here finally they are written like this, no problem. But please remember this formula. This is finally important. Okay, this previous derivation and all not important. Finally, because you know this formula already, this and all already you know. But here what you have to remember, here you have to remember this formula without any struggle. Always you have to remember this formula. Okay, so you know that omega radiated, this is the total power radiated, and again total power means that is like a watt. Then this is some term, I call this term as a radiation resistance and I square RMS. Just I'm comparing with the circuit analysis. When I have a power in watt, I square in one end, then the other way here I have to get a resistance. So that resistance I call it as a radiation resistance. So RAD, so radiation resistance. Okay, radiation resistance that is equal to 80 pi square dl by lambda whole square. Okay, sometime in the exam they used to give, instead of 80 pi square, they used to put 800 also approximately, because you know pi square value is 10. Some exam, again you have to remember this, because 800 like this also, because pi square is 10. 800 dl by lambda whole square. Generally the confusion is here, for most of the people the confusion comes here, whether this is 80 pi square or 80 pi. Generally that confusion comes, because that's why I'm giving you this. Okay, 800, please remember 800. Then 800 is similar to 80 pi square. So finally what is correct? 80 pi square into dl by lambda whole square is correct. So anyway they will give you dl value. then very easily you can calculate this value. In the exam, they used to give like this. Say if my DL value is equal to lambda by 10, then what is radiation resistance? Like this they used to ask. Then as per the formula, what is the radiation resistance? 800. Okay, DL by lambda whole square. What is DL value? DL value is lambda by 10 by lambda whole square. Lambda cancel. What is 10 square? 10 square is 100. So finally 8 ohm is the answer. Like this they used to ask questions in the exam. So for that you have to remember that formula. Okay, you have to remember that formula. Okay, so now finally the radiation pattern RR is equal to 80 pi square dl by lambda whole square. This you have to remember without any struggle. And again you may ask one doubt, if dl is keeps on increasing, then what happens to RR, radiation resistance? Somebody may have a doubt like this. If I put, what happens if I put dl is equal to lambda by 4 and I put dl by lambda 4, whether it will give you the radiation resistance of lambda by 4 antenna? That question may arise. Definitely that will not give, because this formula is valid only when L is very less than lambda by 10. Okay, when L is very less than lambda by 10, or otherwise L is less than lambda, very less than lambda, or L is in the range of lambda by 10, then only this formula is valid. When you take lambda by 4, L is lambda by 4, that lambda by 4 is comparable to lambda, then you cannot use this formula. So this formula you have to use only when L is very less than the lambda. L is very less than the lambda. Okay, so where you have to use when, because we started with that condition only. Okay, so L is very less than lambda, there only you have to